Welcome to Mr. Baker's House of Knowledge. All right, today we're going to talk about uh, parallel lines and their relationship to slope. So, one of the key concepts we know about is we know the 5 ways to prove lines parallel, but that usually involves a transversal. And so, what do you do if you don't have a transversal? What if you just have the 2 lines? Well, if they're on the coordinate plane, you can decide whether or not they're parallel by comparing their slopes. If the slopes of 2 parallel lines are equal, or if the slopes of 2 lines are equal, then the lines are parallel. So let's take a look at this situation here. We've got line 1. I can find out the slope of line 1, so I think that's what I'm going to do. I'm going to find out the slope of line 1. I'm going to do that using m with a subscript L1. That means the slope of line 1. We know the formula for that is the y2 minus y1 over x2 minus x1. So that's going to be our formula for finding the slope. I'll just plug that in. So here's one point on line 1, and here's the other point on line 1. I'm going to do 5 minus a negative 4, which would be 5 plus 4. And I'm going to compare, or I'm going to put that over negative 1 minus 2. So 5 plus 4 is 9. Negative 1 minus 2 is negative 3. So when I simplify that slope, I come up with negative 3. I'm also going to find the slope of line 2. Same procedure here, my 2 points on line 2. So I'm going to do 3 minus a negative 4, which would be 3 plus 4, over negative 3 minus a negative 1, which would be negative 3 plus 1. That's equal to 7 over negative 2. That does not simplify. Since 7 over negative 2 does not equal negative 3, line 1 is not parallel to line 2. Their slopes must be equal for the lines to be parallel. So now what I want you to do is I want you to pause this video and I want you to practice this technique using this problem right here. All right, hopefully you're finished with your practice. Let's see what you got. I'm going to find the slope of line 3. And for line 3, I'm going to set it up as 2 minus 6, the y2 minus the y1, over negative 1 minus a negative 13, that would be negative 1 plus 13. So setting that up will give me negative 4 over positive 12, which is negative 1/3. You might be saying, now Mr. Baker, couldn't I have done 6 minus 2 over 13 minus a negative 1? And that would be 13, negative 13 plus 1. And yes, you could do it that way. If you do, you'll get the negative 12 in the bottom, the positive 4 in the top. It'll still simplify to negative 1/3. So it doesn't matter which one you choose to be your y1 and y2, and your x1 and x2, or your y2 and y1, x2 and x1, or you could do y2 and y1, x2 and x1. It doesn't matter. You'll get the same answer either way. Find the slope of the other line. And so when I find the slope of the other line, it's going to be, I'm going to do 7 minus 6 for my y2, y1. And I'm going to do 6 minus 3 for my x2 minus x1. This gives me a positive 1 over a positive 3. Since negative 1/3 does not equal 1/3, then I know that L3 is not parallel to L4. So hopefully you got those right. Don't worry about if you reverse these numbers right here. If you still got the slopes as 1/3 and negative 1/3, you're most likely doing it correct. All right, the other thing we can do is we can write an equation of a parallel line given some information. If I know that one line is parallel to another line, and I know that this new line contains a point, then I can write a line, an equation of the new line that's going to go through this point that'll be parallel to this line. The first thing I need to recognize is that when you have parallel lines, they have the same slope. So the slope in this line was -3 because it's in the form of y is equal to mx plus b, and so its m value is -3, which represents its slope. So I know that the slope of my new line is also going to be -3. I like to call that the parallel slope. If two lines are parallel, they have the same slope, so because it's parallel to another line that has a slope of -3, its slope is also going to be -3. And then, of course, I have a point, -1, 8. That would be an x1, y1 situation right there. So what do I do with this information? I've got a point and I've got a slope. Do I have enough information to write an equation of the line? And the answer is yes, I do, because I know the point slope form. Y minus y1 is equal to the slope times x minus x1. All right, so what I'm going to do is I'm going to substitute in all of the known values. Y remains a variable, y1 gets an 8, slope is -3, x remains a variable, x1 gets a -1, and then when I simplify that, that's going to be y minus 8 is equal to -3 times x plus 1. So that's the equation of the line in point slope form. If I give you directions that tell you that you need to solve this equation in slope intercept form, we're going to have to do a little bit of modifying here. So let's just real quick take a look at how I would change this point slope form to a slope intercept form. So I'll just move this over here so I have room to work under it. Kind of messed that up a little bit. Let's see if I can fix that. No, I'll just leave that like it is. You can go back and rewind the video if you wanted to see this stuff. So to put this into slope intercept form, the first thing I'm going to do is distribute. So that's y minus 8 is equal to -3x minus 3. That's the distribution. And then I'm going to add 8 to both sides. When I add 8 to both sides, -3 plus 8 is a plus 5. So there we have y is equal to -3x plus 5. That's your solution for having the second parallel line, or the second equation, and it's going to be parallel to this first equation. Notice that they still have the same slopes, but they have different y-intercepts. If I were to sketch a graph, the graph of the original line might look something like this, and the graph of the parallel line would be up here, and it would look like this. So they're both parallel. They'll never cross. They just go through different points on the y-axis. That's represented by having a different y-intercept, so that makes sense to me. All right, so what I want you to do now is I want you to pause this video, and let's see if you can't change or write the equation of a line that's parallel to this line but goes through this point. All right, hopefully you've been able to successfully solve this. The first thing I would want you to do is I would want you to be able to recognize that the slope, the parallel slope, is just equal to -1. There's a negative symbol in front of the x, so y equal mx plus b. This value right here would just be a -1. And then, of course, you're dealing with the point -5, 3, so that gives you your x1, y1. So if I don't give you any further directions and I just tell you to write the equation, then y minus 3 is equal to -1 times x plus 5, because minus a -5 is plus 5. That would be sufficient. If I tell you to put it into slope intercept form, you might need to go further. To go further, we would say y minus 3 is equal to -x minus 5. Then we would add 3 to both sides, and y would equal -x plus 2. And that's the slope intercept form of the equation of a line that's parallel to this line and goes through this point. By the way, notice if you plug these values in here, if I plug a -5 into -x, that's a -5, which is a plus 5, and then 5 plus 2. Oh, so I've caught my own mistake by plugging in values and checking. So what did I do wrong? I'm supposed to add 3 to both sides, and -5 plus -3 is not a positive 2. So it's always very valid to go back and check your work for these careless mistakes that you'll make. So now when I plug it in, I get negative. A negative 5 is a positive 5. 5 minus 2 is 3. When I plug 3 in for y, 3 equals 3, and that makes sense. So little trick there to save you some embarrassment on a test by making a careless sign error is to go back after you're done and check your work. All right, the other thing I want to talk to you about today is the fact that we can decide based on a line's slopes whether or not the lines are perpendicular. Now this is a little bit more difficult because to be perpendicular, you have to have the product of the line slopes be -1. Well, let's think about some things that make a product of -1. If I start out with 3 and I want to multiply it by something and get -1 as an answer, what would be the number that I would have to multiply 3 by? And I'm sorry, I put a plus there, but it should be multiplication. What would be the number that I would have to multiply 3 by to make the answer -1? Well, this is just a simple equation that we can solve by dividing both sides by 3, and the answer is x is equal to -1/3. So I'm going to introduce the concept of creating a negative reciprocal. You're probably not going to have to write an equation every time you want to do this. You can just simply invert the number and change its sign. So for example, if I wanted to find the negative reciprocal of 2/3, that would imply that the negative reciprocal is, well, this is positive, so it's got to be negative, and flipping the fraction is 3/2. If I wanted to find the negative reciprocal of 1/2, I would flip it and change its sign. That would become positive 2. If I want to find the negative reciprocal of -1, I would flip it. Well, that would be -1 over -1, and I would change its sign, so it would become positive 1. There is no negative reciprocal of 0. So interestingly enough, we can't use a horizontal line to determine and compare its slope to something else and determine if the lines are perpendicular. So we have a special rule. Any horizontal line and any vertical line are always going to be perpendicular. So that's how you get around the fact that there's an undefined slope at a vertical line. And how do you multiply undefined by anything? Well, we just ignore lines with slope 0 and lines with slopes undefined. We just allow those lines to be declared as perpendicular. All right, so in this particular problem right here, we're going to decide if these two lines are perpendicular. So the first thing I need to do is I need to find the slope of line 1. The slope of line 1, I'm going to set it up as 2 minus a -4. So that's 2 plus 4 over -4 minus 0. And so 2 plus 4 is 6, -4 minus 0 is -4. And when I simplify that, I get -3 over 2. And the negative sign can go out in front of the fraction, as you remember when you learn how to do fractions, or it can go with the numerator, or it can go with the denominator. Finding the slope of line 2, I've got, I'm going to do -3 minus 3 over -5 minus 4. So that's going to be a -6 in the numerator, a -9 in the denominator. Negative divided by a negative is a positive. 6 over 9 reduces to 2 over 3. So when I go and I multiply -3/2 times 2/3, I get -1 as an answer. That's exactly what I wanted. I wanted these two to be negative reciprocals of each other to decide that these lines are perpendicular. So therefore I can say that L1 is perpendicular to L2. And by the way, the mathematical symbol for perpendicular is like an upside down T. All right, so what I want you to do now is I want you to pause this video, and I want you to decide if these two lines are perpendicular and show your reasoning by showing your work. All right, hopefully you got the correct answer for that. Let's go through and work it and see what we did. So line 3 slope is going to equal, I'm going to do negative 1 minus 7 over 3 minus 2. So negative 1 minus 7 is a negative 8. 3 minus 2 is a positive 1. That's going to simplify to negative 8. And then the slope of line 4 is going to be 7 minus 6 over 8 minus a negative 2. That's 8 plus 2. So that gives me a positive 1 over a positive 10. So if I multiply negative 8 and 1/10 together, I do not get negative 1. So therefore, line 3 is not perpendicular to line 4. Close, but not quite. Hopefully you got this right, and you're ready to move on to the next concept. Now remember when we were doing parallel lines, we could write the equation of a line that was parallel to another line by recognizing what the slopes were and realizing the slopes were the same. We can do the same thing for perpendicular lines too, except there's just a little bit more figuring we have to do. I know the slope of this line is equal to 1/5. And if I say I'm looking at a line perpendicular to that line, then I am allowed to create a new slope by taking its negative reciprocal. So what is the perpendicular slope to 1/5? The perpendicular slope to 1/5 is going to be negative 5. And once again, I already have an x1, y1. So I can go back and I can write the point slope form. Y minus y1 is equal to m times x minus x1. I'm using this formula because I have a point and I have a slope. I plug in the values. So this would be y plus 4 is equal to negative 5 times x minus 15. If I want to convert this back into a slope-intercept form, I can distribute. Plus 75. 5 times 5 is 25, carry the 2. Yep, 75. And then I can subtract 4. So y is equal to negative 5x minus, or I'm sorry, plus, because I'm subtracting 4, 71. This would be a great time to plug the 15, negative 4 in and see if I get an answer. So if I plug in 15 for x, then that's going to be negative 5 times 15 is a negative 75. Negative 75 plus 71 is a negative 4. And sure enough, this side would be negative 4. When I substitute in negative 4 for y, it would be negative 4. That checks. So I'm pretty confident in that answer. I would always encourage you to check your work so that you can be confident in your answers. That's one of the biggest reasons I think people don't score high on tests is because they make careless mistakes. So a good student always, if they have time, checks their work. So what I want you to do now is I want you to pause this video and I want you to write the equation of a line perpendicular to y is equal to negative 3x minus 5 and going through the point negative 3, 7. It doesn't tell you what form to write your answer in, so I want you to put your answer in slope-intercept form. All right, so hopefully you were able to do this okay. Let's take a look. I'm going to create a perpendicular slope. The perpendicular slope is formed by the negative reciprocal of this line slope. This line slope is negative 3. When I take the negative reciprocal of negative 3, I get a positive 1/3. And then, of course, I already have negative 3, 7 as an ordered pair. That will be my x1, y1. I've got a point and a slope, so I write the point slope form. Y minus y1 is equal to m times x minus x1. Hopefully you've been writing this and seeing this enough now that you might even already have it memorized and you won't need it on a formula sheet. When I plug stuff in, I get y minus 7 is equal to the slope, which is 1/3, times x minus a negative 3 would be x plus 3. All right, then I'm going to go through and I'm going to distribute. Things are going to look a little bit trickier when we put this back into slope-intercept form because we might have to deal with some fractions because that's a fractional slope there. Let's see what happens. So y minus 7 is equal to 1/3 x plus 1. And then I add 8 to both sides. Y is equal to 1/3 x. 1 plus 7 is 8. So I'm adding 7 to both sides, and when I do that, I get plus 8 here. So that's your solution in slope-intercept form. Hopefully you were able to do that. All right, now that you've seen all of the lesson, you are prepared to do the homework off of page 201, 7 through 25. Just do the odds, and then 36 through 38. I hope you enjoyed this lesson.